Good afternoon, everyone. My name is Jae-Won, and I'm currently working as the postdoc at Georgia Tech. Today, I'm excited to talk about our research, DLBox, a new model training framework for protecting training data. This work was done by me, Juwon Lee, Cheol Myung, Sang-Yoon Kim, Young-gi Lee, and my post-advisor, Byung-Young Lee. So let me start with a simple example. Here is a hospital who has a large amount of medical data set. So let me call them data owner. And here comes an AI developer who wants to train an AI model that detects cancer based on X-ray image. But they do not have enough amount of data, the X-ray image, so they want to borrow it from the data owner. So they say they want to borrow the X-ray image and they will train only on AI model, but nothing else. So the poor data owner sent them the data. However, the AI developer were the bad guy, so the data becomes theirs. So what's the problem here? The data owners share their data to the AI developers. Then what is the sharing the data? It means allowing to use the data, but in a permitted way. What the data owner wanted was to train only on AI model, but nothing else. Then what is sharing data for model training? So let's say again, here is the data. Training a model is the same as applying a sort of function on the data. Then the result, if the result is a benignly trained model, then it will be allowed. But if it is not the trained model, such as just the result is the data itself, then it should not be allowed. However, until now, still there was no systematic solution to protect the shared training data in the model training. So once the data is handed over to the AI developers, they can do whatever they want with the data. And still, this is the big hurdle in deep learning industry. So let me talk about how the AI developers can leak the data. Since there is no systematic protection at all, actually the AI developers can do whatever they want. The simplest way would be to just leak it as itself. They can just leak it through the network or leak it through the external hard disk. However, even if we protect such trials by providing the air-gapped environment, still they can leak the data through the model. For example, they can just embed the data into the model and decode it later, or they can bias the training procedure so that the AI model resembles the data. Or also they can launch gradient inversion attack. Actually, they can do whatever you can imagine. And until now, no one knows how to prevent such data leaks. So we propose DLBox to protect the shared training data in model training. DLBox takes the data from the data owner and the model training code, we name it function, from the AI developers. Then it trains the model on the data and return the data return the model if it is benignly trained. But it prevents any unauthorized data leakage, such as leaking the data itself, or leaking the partial data, or even leaking the data through the model. However, to be honest, it is infeasible to completely prevent data leak. Let's think about how the DLBox should work to prevent data leak. It should check the model training code, so-called function, developed by an AI developer. So then, what's the desired properties of the functions? First, the allowed function should be able to train an AI model. However, because this is the original goal of model training. But on the other hand, to prevent data leak, we should not be able to get any information of the input, so-called the training data, from the output of the functions. However, these goals are actually conflicting goals. As long as the trained model has reasonable performance on the task, it should remember some sort of information of the data, and obtaining that model means that the data is already leaked. So actually, it is impossible to completely prevent data leak. Then you may wonder what DLBox wants to do. Let's say here are all the functions that we can implement. Then among the functions, there will be the functions that leak the data. And among them, there will be the functions that benignly train the model. But on the other side, some functions will maliciously leak the training data. So what we want to do is allow only the benign model training, but prevent such malicious attempts. Then the question comes to our mind, what is the benign model training? To this question, what we found is that the benign model training is a statistical process of learning common patterns from a dataset. So there is no need to prioritize or discriminate a specific sample because each sample in the dataset has equal importance to the model. And all the samples in the dataset should have fair contribution to the model. Based on these observations, we defined DGM rules to determine whether a model training is benign or not. The data samples should go through the same augmentation, and G, the gradients should be backpropagated from the equally computed loss value. And finally, the M, the model, should be updated only by adjusting all the gradients. So let me explain these DGM rules with a standard, the typical model training procedure. So here are n samples and the model that we want to train. The first procedure of the typical model training would be to augment the samples, such as flipping the image or adding a random noise. However, the point is that no one sample will be specially cared or ignored because all the samples have same importance to the model. So they will go through the same augmentation and the loss values will be equally computed. Then the gradient will be computed through backpropagation and all the gradients will be averaged and adjusted to update the model. And actually the model training is the repetition of this procedure. So we can say that the DGM rules are preserved in the typical model training. And based on these rules, we design a DLBox to enforce DGM rules while model training. So DLBox is composed of two components, DLSandbox and DLOracle. DLSandbox sandboxes an untrusted AI developer's code from illegally leaking the training data. So it sanitizes all the outgoing data flows of the training data, and it is also protected by an enclave of confidential computing. Then, inside the DLBox, the DLOracle analyzes all the computations on the data to check whether the trained model satisfied the DGM rules or not. So let me explain the design with a simple example of model training. Here is an MNIST model training code using PyTorch. So by default, running this code will allocate all the variables, including the training dataset, shared training dataset, and the user-defined variables in the same address space. So it means that the AI developers have full control over the data. So they can just leak it through the network or some other I/O. So what we first do is to isolate this address space into an unsafe one where an untrusted code runs, and the safe one where the training data is loaded. And so in this isolated space, the attackers cannot directly access or modify the data. But instead we provide the proxy variables to reference the object in the safe address space. Then the AI developers invokes an operation on the data through invoking a sanitized API. Then finally, the new proxy variable will be assigned to the resulting object. So the process goes on this way, and while the process goes on, the DLOracle will monitor all the operations on the data. So finally, when the model is trained, it checks whether the DGM rules are satisfied, and only when it's satisfied, it returns the data, the trained model to the AI developers. So we implement this framework using PyTorch to support real-world machine learning models, and we used AMD SMP to protect the DLBox. And to evaluate the security enhancement of DLBox, we measured the number of samples leaked by one transfer of seemingly trained model. Here I say seemingly trained because the untrusted AI developers can do whatever they want, not only training the model. So here, and we used 3 image datasets to measure the numbers. And with the baseline, which does not have any security measure, the attackers can leak 100% of the samples with only one trial, because there is no protection. But even with an ad hoc protection, they can still leak a significant portion of the samples. But with DLBox, we checked that almost no samples are leaked through the model training. So, and we also evaluate the performance by training the image and language models on DLBox, and we found DLBox imposes 4% overage of training time on average. So to conclude my presentation, we designed a new model training framework to protect the shared training data, and we believe DLBox can foster the data sharing by protecting the rights of data owners. Thank you for listening, and I'm happy to answer the questions.
Thank you for your presentation.
Yeah.
Any question from the audience? We can take one question.
So thanks for the talk. So if I'm understanding this correctly, so it's a secure enclave that only allows the normal procedure of training a model, right?
Yeah.
So can you please clarify what do you mean by the number of examples that is leaked after?
You mean this?
Yeah, you're saying your adversary is reconstructing data points from the model it releases, right?
Yes. Basically, the attackers can do whatever they want in model training. So in the baseline scenario, they can the attack method. The attack method here is the attack method used in the to leak the data. In the baseline scenario, they can just leak the data itself. So they so 100% is leaked. But they can also, if they embed the data into the model, then the later decoding the model will leak this amount of data. But also, this is actually there is a reference, one CCS paper that biasing the model training to make the model resemble the data. By doing such attack, then after decoding the model, then they can the attacker can reconstruct an image that are almost similar to the original dataset. Yes. And the criterion is like we just defined, but you can see the actual image is very similar. So
yes, thank you. So my point is that the secure enclave is designed to ensure that the model is honestly trained, but honestly trained model may also leak information. And
yes,
yeah, that's my point. Yes.
Yes.
Thank you.